Hello everyone, this is Minh Nguyen, and I'm here to give you a video presenting the knowledge of the capacitors and their properties in a resistor capacitor DC circuit. So this is the outline that I will present throughout the video. First, we'll identify what is the capacitor, how does it work, the capacitance, and the energy stored in a capacitor. So the capacitor is a set of two plates, mostly made of metal, and they are separated by an isolated medium. When the capacitor is charged, one plate will gain positive charge, while the other will gain negative charge. The reason for this is that the electrons will be stripped out from the negative plate and they will move to the positive plate. This is the capacitance. The capacitance measures the capacitor's ability to store charge. The higher the capacitance, the more charge that each plate can store. It is measured in farads. From this definition, it can be run out that the equation to calculate C is C equals to Q over V. However, the factors that affect the capacitance are the area of the plate, the distance between two plates, and the permittivity of the insulator. The equation is C equals to epsilon 0 times epsilon R times A over D. Capacitors store energy in form of electric field. The equation for the energy stored is W equals to 1 over 2 C times V square, or 1 over 2 times Q square over C, or 1 over 2 times QV. We move to the second part and investigate how the capacitors behave when they are in series and in parallel. When the capacitors are in series, the amount of charge that each capacitor store is the same, and the total capacitance is calculated by the equation 1 over C equals to 1 over C1 plus 1 over C2 and so on. Capacitors are in parallel, the voltage between each capacitor is the same, and the equation to calculate the total capacitance is C equal to C1 plus C2 plus C3 and so on. Move to the last part to analyze the charging phase and the discharging phase of the capacitors while it is in series with the resistor. We built a circuit using Circuit Construction Kit Virtual Lab. You can find the links to download it below my video. So I will turn on the circuit. And as you see here, this is the graph of the voltage across the capacitor as well as the current flowing through the resistor. The voltage chart has the positive slope, but the slope is decreasing while the current has negative slope, and it is increasing in magnitude. For the charging phase and the discharging phase of the RC circuit, we have a constant time equal to RC, and we have the equation for the charging phase and discharging phase showing here.